Yes, hello and welcome to the physics class. And today we are going to do some numericals on the chapter electricity. So before going to the question, first let's summarize the formulas which used in this chapter. Okay, so first formula is Q equals to NE. This formula represents the quantization property of the charge, which means total charge is always equal to the integral multiple of the charge of one electron. Here N represents the integral number. Okay, and the next one is I equals to Q by T. It means I represent the current, and current can be calculated as the rate of charge flowing. Okay, Q upon T. Here Q represent the charge. And third one is V is equal to I, which is very famous and known as Ohm's law. Ohm's law's mathematical expression is V equals to IR. Here V is potential difference between the terminals and I current, R is resistance. And fourth one is R equals to rho L upon A. We know that the resistance depends on the resistivity of the material, length of the wire, cross section area of the wire and the temperature. Okay, but here we are using only three terms: resistivity, length and cross section of the wire. So by this we can calculate the resistance and resistivity both. Fifth one is combination of resistance. We know that there are two types of combination: series combination and parallel combination. If there is parallel combination, then we can find the resultant resistance by the sum of the resistance. How many resistance are given in the combination can be written like this and can be sum after this. And in the series combination, just simply sum all those resistance which are used in the combination. Okay, and next one is work, which is equals to the product of Q and V. Here Q is charge and V is potential difference. The total work done is equal to the product of total charge and potential difference. Okay, here H represent the heat. Heat is equal to the work done, as we discussed in the our last topic, which is equals to, or we can say heat is calculated as the product of I square RT. I current, R resistance and T is time. And next P is showing electric power. Electric power can be represented in the three terms, or we can say in the three types of expression. First one is P equals to I square R. Second one is P equals to V square R. First this and second this, and third one V multiply with I. So if we have value of I and R, so we can calculate the power. If we have value of V and R, also we can find the value of power. And if we have value of V and I, in this case we also can find the power of any electrical appliance or any system we are using. Okay, so our first question is, a current of 1 ampere is passed through a resistor. Resistor means the device which produces resistance, 20 ohm. For 1 minute, find the heat produced in the resistor. So the solution for this. So first, let's understand the question. What is question is saying? Yeah, what is question is asking? A current of 1 ampere is passing through a resistor. So first, let me draw a resistor. Its capacity is 20 ohm. It means this resistor offers 20 ohm resistance, and 1 ampere current is passing through it for the time period of 1 minute. Okay, so how much heat produced in this resistor? Okay, because we know that if someone is resisting the current or flow of charge, then it produces heat. So the given terms in question, we have given current I equals to 1 ampere, resistance R equals to 20 ohm, okay, and time T equals to 1 minute, which is also equals to 60 seconds. And why we need to convert this unit? Because SI unit of time is second. Now we have to calculate heat. So as we know, the formula for heat, H equals to I square RT. I here I represent the current, R represent the resistance, and T represent the time. So by putting this value, current is equal to 1. So I square multiply with R is 20 ohm, and time is 60 seconds. So by multiplying this, we get 1200. 1 square 1 multiply with 20, 20, and 20 multiply with 60, which is 1200. And what is the unit of heat? So heat is equal to the work done. So the unit is also same for the heat as work. So finally unit 1200 joule is our answer. Now, second question. The question is, a resistor of resistance 20 ohm is connected across a potential difference of 20 volt for 1 minute. Calculate the heat produced in resistor. Okay. In the last question, we have the value of current and resistance. Now, in this question, we have the value of resistance and potential difference. So, in this case, how we calculate the value of heat produced in the resistor. ओके इससे लास्ट वाले क्वेश्चन में हमारे पास वैल्यू थी करंट 1 एम्पियर एंड रेजिस्टेंस 20 ओम था, बट इस क्वेश्चन में हमारे पास वैल्यू है रेजिस्टेंस 20 ओम और पोटेंशियल डिफरेंस यानी कि आई की बजाय वी गिवन है क्वेश्चन में. सो इसको कैसे सोल्व करेंगे? तो क्वेश्चन के अकॉर्डिंग रजिस्टर, here is a resistor which is resistance is 20 ohm and it connected across a 20 volt potential difference. Okay, and the current passing through this resistor for 1 minute. Okay, so what are the given terms? Resistance R equals to 20 ohm and V equals to 20 volt, and time again that is 1 minute. So we have to convert it into seconds because all these units are SI units, so we have to convert time into its SI unit. Okay, now we know that H equals to I square RT. We have to calculate here H. हमें H calculate करना है. H का formula होता है I square RT. Okay, but in this question I is absent, or we can say I's value is not given in the question. So how we can find out is, suppose as we discuss the topic electric power, so the value of power P equals to I square R. Okay, and again one of the relation is V square upon R. बोथ द रिलेशन सेटिस्फाई दी टर्म्स इलेक्ट्रिक पावर, यानी कि पावर को आप इन दोनों टर्म्स में एक्सप्लेन कर सकते हैं. तो यहाँ पे हमारे पास है आई स्क्वायर आर और यहाँ पे भी आई स्क्वायर आर एंड वी स्क्वायर आर. सो बाय दिस इक्वेशन वी कैन राइट आई स्क्वायर आर इज इक्वल टू वी स्क्वायर अपॉन आर, बिकॉज दोनों ही पी की ही वैल्यू है. सो ये दोनों ही इक्वल होंगे. सो आई स्क्वायर आर को मैं रिप्लेस कर सकता हूँ वी स्क्वायर आर से. ओके, गेट दिस पॉइंट? So here after this I'm writing here H equals to V square upon R and T. Okay, so what is the given value of V is equal to 20, so I am putting here 20 square, and what is the value of R is 20 into 60. Okay, so we can just divide 20 square by 20, so here left only 20. Here we can write 20 square into 20 into 20 into 60. So cancel this, and again 6 to 12, and the unit of heat is joule. So H is equal to 1200 joule. Here is your answer. Once again एक बार और देख लेते हैं. In this question we have given value of potential and resistance, and the formula of H we know that, which is I square RT. So here we don't have the value of I. So by the relation of electric power, तो यहाँ पे हमारे पास I की वैल्यू गिवन नहीं है, सो हम इलेक्ट्रिक पावर के रिलेशन को यूज करके I की बजाय V को रिप्लेस करेंगे. सो P इज इक्वल टू I square R and P is equal to V square upon R. So both the value of P, so we can write I square R is equal to V square upon R. Here it I'm writing again. I square R is equal to V square upon R. Okay, so just put this value on the place of I square R. So I square R is replaced by the V square R upon into T. Okay. In our last two questions, we learned that how we can calculate heat by various methods. Okay, now we are going for the third question, and the question is how much energy is given to 1 coulomb of charge passing through a 6 volt battery. यानी कि किसी चार्ज को कितना एनर्जी नीड होगा अगर उसे 6 वोल्ट की बैटरी, या 6 वोल्ट में पोटेंशियल डिफरेंस इज 6 वोल्ट इज गिवन. ओके, तो 6 वोल्ट की बैटरी 1 कूलम चार्ज को 6 वोल्ट के पोटेंशियल को पास करने में कितना एनर्जी का नीड होगा. ओके, सो फ्रॉम द डेफिनेशन ऑफ पोटेंशियल वी नो दैट V इक्वल्स टू W upon Q. Okay, so what is the definition of potential? The work done to bring a unit charge from infinity to the electric field. Okay, the potential is work done and bring a unit charge from the infinity to electric field. So V is equals to W upon Q. So here we can write W is equal to V cross Q, meaning V multiply with Q. Here W represent the work done, and we know that W is also always equals to the energy. W is always equals to the energy, and here we have to calculate energy, means we have to calculate W. So given values of V equals to 6 volt and Q equals to 1 coulomb. So simply W equals to E equals to 6 into 1. So here 6, and if we are calculating work, so the unit of the work is joule. So the final answer is 6 joule. So here we can say that 6 joule energy is given to the 1 coulomb charge for passing through a 6 volt battery. Yes, now question number 4. A 6 ohm resistance wire is double on it. Calculate the new resistance of the wire. यानी कि एक वायर है जिसका रेजिस्टेंस 6 ओम है, अगर इसे आप डबल कर देते हैं इसकी लेंथ को, सपोज ये कोई वायर है, अभी इसका रेजिस्टेंस 6 ओम है, अगर आप इसको लेंथ से ऐसे मुड़ा के डबल कर लेते हैं यानी कि लेंथ हो जाएगी इसकी हाफ. ओके, तो इस केस में इस वायर का रेजिस्टेंस क्या रहेगा, क्या उसमें कोई चेंज आएगा या सेम रहेगा एज इट इज जैसा प्रीवियस केस में था. सो द फॉर्मूला फॉर कैलकुलेटिंग R means resistance is R equals to rho L upon A. Okay, initially it is 6 ohm. Okay, R is 6 ohm which is equals to the rho L upon A. So same वायर को हम फोल्ड कर रहे हैं, it means रेजिस्टिविटी सेम रहेगा. रेजिस्टिविटी डिपेंड करती है जिस मटेरियल से वायर बना हुआ है. सो मटेरियल तो सेम है तो रेजिस्टिविटी चेंज नहीं होगी. अब बात करते हैं लेंथ और क्रॉस सेक्शन एरिया की. सो लेंथ, अगर उसी वायर को हम बेंड करके डबल कर रहे हैं तो लेंथ हो जाएगा हाफ, यानी कि नाउ न्यू लेंथ इज L/2. Okay, initially length was, we are suppose that initial length is L, so now new length is L/2, and cross section area, न्यू क्रॉस सेक्शन एरिया इज, सपोज इसी वायर को डबल किया गया है। इनिशियली ये पूरा एक वायर था जिसे फोल्ड करके डबल कर दिया है। ओके, सो लेंथ हो चुकी है इसकी हाफ, बट क्रॉस सेक्शन एरिया जस्ट डबल हो चुका है। क्रॉस सेक्शन एरिया इस तरह से डिफाइन करते हैं। ओके, सो क्रॉस सेक्शन एरिया हो चुका है डबल, इट मींस 2a। इनिशियली द क्रॉस सेक्शन एरिया वाज a, so now cross section area is 2a। so now calculate the resistance R equals to rho, new length is L by 2 and new cross section area is 2a, so L rho L upon 4a। okay, get it? यहाँ तक clear? Then from the equation 1 we know that the value of rho L upon a is equal to 6 ohm। so here rho L upon a, so we just replace rho L upon a from the equation, that is 6 upon 4। okay, rho L and a is equals to 6, so here I am writing 6 and the remaining 4 is here, so 6 by 4 1.5 and resistance है so unit ohm। so after, so the initial resistance of a wire is 6 ohm and we are just doing it fold by its half length, so the length will be L by, new length will be L by 2 and the cross section area, if the initial cross section area is a, then now its cross section area is 2a। okay, so by this method we can calculate it। okay, yes, now question number 5। in this question an electric circuit is given in which R1, R2, R3, R4 and R5, 5 resistance are connected in the series or parallel combination. What we have to find, one meter is attached and a 12 volt battery is supplying power in this electric circuit। so for this circuit we have to calculate the total resistance and total current flowing in this circuit। so here we have 5 resistance, so first of all we have to calculate the equivalent resistance for both the combinations। okay, so for these circuit here we have R1 and R2। okay, so for R1 and R2 we have equivalent resistance, this is R1 and R2 in the combination of parallel or series, these are in parallel combination। okay, so the formula for equivalent resistance in parallel combination is 1 upon R equals to 1 upon R1 plus 1 upon R2। clear? okay, so 1 upon R is equals to 1 upon, what is the value of R1 is equal to 10 plus 40, 1 upon 40, so 1 upon R equals to 10 and 40, the LCM is 40, so here we have 4 plus 1, it means 5 upon 40, so R equals to 40 upon 5, which is equals to 8 ohm, means we can write on the place of R1 and R2 just 8 ohm, equivalent 8 ohm, so we can replace the R1 and R2। so here we are replacing R1 and R2 by a equivalent resistance which value is at ohm। okay, and here we are showing it by R dash। okay, and now for this term here again R3, R4 and R5 are in parallel combination, so again we have to calculate the equivalent resistance for these three resistance, so 1 upon R, here I am showing R double dash for this equivalent resistance, 1 upon R3 plus 1 upon R4 plus 1 upon R5। okay, so 1 upon R double dash is equal to 1 upon 30 plus 1 upon 20 plus 1 upon 60, and the LCM is 60, so 2 plus 3 plus 1. Okay, 2 plus 3 plus 1, तो मैथमेटिकल कैलकुलेशन है, आप इजीली कर सकते हैं. 2 plus 3 plus 1 upon 60, 2 3 5 plus 1 6 upon 60. So here I am writing 6 upon 60, 1 upon r double dash, and r double dash equals to 6 by 60, so 10 ohm. Okay, so on the place of R3, R4 and R5 we can write as a single equivalent resistance R double dash and its value is 10 ohm. Okay, so now in the electric circuit we have two resistance, one is 8 ohm and one is 10 ohm, and these two resistance now in series combination, so easily we can find out the equivalent resistance for this electric circuit. So total resistance is, because these two are in series combination, so the formula to find equivalent resistance in series combination is R equals to R dash plus R double dash. आई होप क्लियर कि हमने इनको सिंपली प्लस क्यों किया. हमने इस फॉर्मेट में ना लिख के इस फॉर्मेट में लिखा है बिकॉज नाउ दिस टू आर इन सीरीज कॉम्बिनेशन. पहले ही सारे रेजिस्टेंस पैरेलल कॉम्बिनेशन में थे तो हमने पैरेलल वाला फॉर्मूला यूज किया है, और अब ये सीरीज में है. ओके, सिंपली इसका एंड इसके स्टार्टिंग पॉइंट से कनेक्ट है, और ऐसे कॉम्बिनेशन को कहते हैं सीरीज कॉम्बिनेशन. ओके, सिमिलरली जो पहले कॉम्बिनेशन थे वो इस तरह से थे, तो इसका स्टार्टिंग पॉइंट इसके स्टार्टिंग पॉइंट से ही कनेक्टेड था, तो ऐसे कॉम्बिनेशन, और इसका एंड पॉइंट से ही कनेक्टेड, तो ऐसे कॉम्बिनेशन को कहा जाता है पैरेलल कॉम्बिनेशन. तो यहाँ पे सीरीज कॉम्बिनेशन है, एंड नाउ वी कैन राइट इट एज R equals to value of R dash is 8 and R double dash is 10 is equal to 18 ohm. Okay, so the answer of the first question, calculate the total resistance of the given electric circuit, that is 18 ohm. Okay, and total current in the circuit, so from the Ohm's law we know that V is equal to IR, and here we have value of V and R, so easily we can calculate the value of current. So here I am writing here we are calculating the value of current. So from Ohm's law V equals to IR. Okay, here we have to calculate I, so I is equal to V upon R, and V is given 12, so 12, and R we have calculated, so the value of R is 18, so I is equal to 2 by 3 ampere. Or further, if we divide 2 by 3, then we can write 0.666 ampere and 0.67 ampere in round off value. Okay, I hope it is clear. So इस तरह के क्वेश्चन में आपको फर्स्ट ये डिसाइड करना है कि कौन से रेजिस्टेंस कौन से कॉम्बिनेशन में ज्वाइन है, वो पैरेलल में है या सीरीज है. आपको उनको सिंप्लीफाई करते हुए जाना है. सबसे पहले यहाँ पे हमारे पास दो रेजिस्टेंस थे, तो हमने इक्विवेलेंट रेजिस्टेंस फाइंड किया, उसे हमने रिप्लेस कर दिया, जो इक्विवेलेंट वैल्यू आई उन दोनों को से. यहाँ पे हमारे पास 3 रेजिस्टेंस थे, उनका हमने इक्विवेलेंट वैल्यू फाइंड आउट किया एंड हमने उन्हें रिप्लेस कर दिया इक्विवेलेंट वैल्यू से। तो अब हमारे सामने ये इलेक्ट्रिक सर्किट बहुत ही सिंपल वे में है, इसे हम इजीली बता सकते हैं कि नाउ दीज टू रेजिस्टेंस आर इन सीरीज कॉम्बिनेशन एंड सीरीज के फॉर्मूले से हम इजीली इसे कैलकुलेट कर सकते हैं। एंड फ्रॉम ohm's लॉ अब I कैलकुलेट कर सकते हैं अगर V की वैल्यू गिवन है और R हमने फाइंड आउट किया है, तो द फाइनल वैल्यू इज 0.67 ओम। ओके।